Good morning. My name is Kaushik, and today my topic in energy from waste is about thermal treatment techniques, which are incineration, gasification, and pyrolysis. So, coming to the introduction for incineration. So, what incineration is? Incineration serves in waste management as a way to treat water through controlled burning. So, this treatment is often used in the production of electricity because it reduces the mass of water up to 96%. So, it is popular among countries like Japan, where the scarcity of land makes incineration a convenient way for the disposal of waste. So, while the incineration is popular way to dispose the waste, the use of combustion also refuse items that could have been recycled or composted. So, many of the waste items incinerated, which they can contain toxins like mercury, dioxins, furans. These produce carbon dioxide and nitrous oxide when burned. The practice for burning refuse waste is can be traced as far as first century AD, where the communities of Israel city and Mayan in Central America burned much of their refuse often. So this burning of rubbish on a larger scale and as a source of energy, this started in 1874 when the first destructive incineration plant was built in Nottingham. So these destructions were capable of producing energy. Then they soon fell from favor for their toxic emissions, coating surrounding communities with ash. These poor record of destructors, the use of incineration continued throughout the 20th and 21st century, with incinerators being better designed for treating waste. So coming to the gasification. So gasification is a technological process which can convert any carbon-based raw material, such as coal, into fuel gas. So this fuel gas the converted material can also be called as synthesis gas or syngas for short. So gasification occurs in gasifier, generally a high temperature or pressure vessel where oxygen and steam are contacted with coal or other feeding material. So these causes a series of chemical reactions to convert the waste into syngas. So syngas is also called because of its history as an intermediate in the production of synthetic natural gas. So primarily these are composed with colorless, odorless, highly flammable gases, which is carbon monoxide and hydrogen. Syngas has a variety of uses. The syngas can be further converted to nothing but hydrogen and carbon dioxide by adding steam and reacting over catalyst in a water gas shift reactor. So when this hydrogen is burned, it creates nothing but heat and water, resulting in the ability to create electricity with no carbon in the exhaust gases. Furthermore, hydrogen, which is made from coal or other solid fuels, can be used to refine oil, or we can make products such as ammonia and fertilizer. Gasification, most importantly, hydrogen enriched syngas can be used to make gasoline and diesel fuel. Polygenerational plants can produce multiple products which are uniquely possible with gasification technologies. Carbon dioxide can be efficiently captured from syngas, which prevents the emission of greenhouse gases to the atmosphere and its utilization or safe storage. Gasification is used as an alternative to more established ways of converting feedstocks like coal, biomass, and some waste streams into electricity and other useful products. The gasification advantages in specific applications are condition, particularly in clean generation of electricity from coal, may make it an increasingly important part of the world's energy and industrial markets. The stable price and abundant supply of coal throughout the world makes it the main feedstock option for gasification technologies going forward. So this is a diagram of gasification where the feedstock which are used are coal, biomass, petroleum, coke, or waste are, are gone through gasifier, and from there gas stream So the solids go down and the gas components go up. So the solids go through oxygen and steam, where again it goes to combustion and turbine. So the gas stream goes to particulates chamber, and there from sulfuric acid, and then is added to H2, which makes fuel cell, which is used for electric power, transportation fuels, and fuel chemicals. So the solids go through ASU by where when ASU releases oxygen into the gasifier, and the air which comes from it goes through combustion turbine, and which then again goes to exhaust through heat recovery and steam generator. Then it goes to steam turbine. So the water is used in this chamber, and the exhaust which comes from it is the waste is CO2 for sequestration, and it forms a stack. So the generator is used near the steam turbine to generate electric power. So coming to the third one, pyrolysis. So pyrolysis involves the chemical transformation of a sample on heating at a high temperature, generally around 400 to 1000 degrees Celsius. So when combined with GC, the technique involves a pyrolyzer in, into which samples to be analyzed are located. Target analytes are typically very high molecular weight compounds. In decomposition, smaller volatile and semi-volatile molecules are generated, and when the analysis is performed without identifying the product components, the resulting chromatogram represents a fingerprint of the original sample. So this is typically used for the characterization of polymers, paints, coatings, polysaccharides, linens, soil, sludge, and sediment samples. Pyrolysis systems are typically purchased separately from but used in line with GC. A variety of detectors are used, but FID and MS are common. A trap may be used to collect pyrolysis products with periodic desorption into the GC, typically by automated thermal desorption. In automated analysis, different modes are possible. Rapid heating to a single temperature followed by GC, programmed pyrolysis during GC analysis, multi-step pyrolysis with GC after each setup. Examples of these pyrolysis applications include the analysis of a few mg of automobile paint from an accident scene to determine the make and model of an automobile. Curie point pyrolysis for characterizing cheeses, the examination of art materials and paper, and the forensic analysis of arson samples. Advances have been reported in the pyrolyzer design to reduce the effect of discrimination against high molecular weight pyrolysis fragments. Thank you.